Yeah, hello everyone. Welcome to IIT Foundation classes 7th class. So this is Srinivas, your maths faculty. Let us go through the concepts what we are going to discuss in this academic year. Okay. So mainly in 7th class we are going to cover the topics of number system and surds, which is also one of the type of a number system. Okay, like irrational numbers. Next, algebraic expressions, one of the topic which is taken from the algebra concept. And the fourth one is comparing quantities, which is useful to your real life for calculating the profit and loss, percentages, simple interest and all. Okay, so those are all topics we are covered in this comparing quantities topic. Next, exponents and powers, how to write the scientific notation of a number also. Okay, so nothing but which is covered in exponents and powers topic. Then sixth one is linear equations. Linear equations is also a algebra topic. Okay. Next, polynomials. This also belongs to algebra. So here from algebraic expressions, linear equations and polynomials. These three topics covered from the branch of mathematics, nothing but algebra. Next, solid shapes, geometry. Solid shapes like 2D shapes and 3D shapes. We are going to discuss focused on both of them, but the name is given as solid shapes, but here we cover the 2D shapes and 3D shapes also. Okay. Next, plane geometry. This is plane geometry. Okay. Now, first one, number system. So today we are going to deal with the topic of number system. Here number system, what are the topics are going to be covered in this chapter? Let us see. So while going to the number system topic, so there are different type of number sets. Set of numbers will be there, nothing but natural numbers, whole numbers, integers, rational numbers, and decimal form of a numbers, whatever. Real numbers also there, irrational numbers, and complex numbers also. But in this number system, mainly we are covering the topic of standard form of a number. First topic is standard form of a number. Standard form of a number. That too, in this standard form of a number, we are going to cover the number of factors or number of divisors, sum of divisors and product of divisors of a composite number. Okay. Next, LCM and HCF. Second topic is LCM and HCF and their relation also. Relation between LCM and HCF of any two numbers. Next, we are going to cover the topic of fractions. Fractions also we are going to cover in this number system topic. Okay. Fractions of the rational numbers. Rational numbers. There is a small difference between fraction and rational numbers. So while we are going to discuss about the rational number, then you will get the clarity about it. Okay. Now the next topic is absolute values. Okay. Next topic about absolute value. Okay. And intervals concept also we are going to introduce in this year. Intervals, which is useful to intermediate concept of functions. How to find out the solution of a function which somewhere to there. That means what are the intervals of the function we are going to solve. We are going to learn in this concept. What are intervals? Okay. Next, we are going to learn the divisibility rules also, and here at absolute value we are going to discuss of concept of unity digit. We are going to discuss concept of unity digit. Very important problems will be given in this concept of unit digits. Okay, right. So intervals, right. So like this, we are going to cover the topics which are related to number system. Clear, children? Yeah. So let us move on to the today's class. Yeah, first concept. What is a standard form of a number? What is a standard form of a number? So before going to discuss about the standard form of a number, so we should know about the fundamental theorem of arithmetic. The fundamental theorem of an arithmetic is nothing but every composite number can be expressed as product of primes. What is the fundamental theorem? Every composite number can be expressed as product of primes. Okay. So before that, you should aware of prime numbers and composite numbers, right? What are prime numbers? To know about the prime numbers, again you should know about what is factor, because we are going to tell about the prime number definition as if a number having exactly two factors, that means only two factors, such type of numbers are called prime numbers. Then you should come to know what is factor. Okay. Now today's class we are going to discuss with multiples, factors, and you should know some idea about what are natural numbers and whole numbers, integers. Okay. Right. So we'll start with natural numbers, then we'll go through what are even numbers, prime numbers, composite numbers, then 1 to 100 how many prime numbers are there, 1 to 50 how many prime numbers. So let us discuss with one by one topic, then we'll go through the standard form of a number. Okay, right. So I think that's according to your standards you must have an idea of natural numbers and whole numbers. Okay, let us discuss natural numbers. Natural numbers are represented with the letter capital N. Simply natural numbers are nothing but counting numbers. Natural numbers are nothing but counting numbers. We usually count from 1, 2, 3 and so on are called natural numbers. So while you are observing the natural numbers starts from the number 1. That means least natural number is nothing but 1 and highest natural number. Can you define the highest natural numbers? No. Highest or largest natural number cannot be determined, because when you count the numbers continuously like that, the numbers will come on. Okay? The flow will come like that only. So that means there is no largest number in the set of natural numbers. It is not defined. Okay? So this is about natural numbers. Next, whole numbers. Whole numbers are nothing but the natural numbers including 0. The natural numbers including 0 are called whole numbers. Here the smallest whole number is 0 and the largest whole number is cannot be determined. Okay, these are always represented with the letter capital W. Next, let us go through the integers. Integers are represented with two letters I or Z. Okay, what are integers? All positive numbers, all negative numbers including 0 are called integers. All positive numbers in the sense 1, 2, 3, 4 and so on. All negative numbers -1, -2 and so on, 0. That means here you should understand that 0 is neither positive nor negative. We cannot decide whether the 0 is positive number or negative number. Okay. So that integers are nothing but all positive numbers, all negative numbers including 0 are called integers, set of integers. Here largest number cannot be determined, as well as smallest number also cannot be determined, because -1 is lesser than 0, -2 is lesser than -1, -3 lesser than -2. It is continuous and so on. It is going on like that. So yeah, here you should understand that integers cannot be identified its largest number and smallest number. Okay. Right. This is about the natural numbers, whole numbers and integers. So let us go through the concept of multiples and factors. Okay. Right. So let us go through the concept of multiples and factors. So simply to define what are multiples and factors, we can just take in a table. Any table you can take. From the table we can decide whether the number is multiple of so and so number or not. Okay, let us take that one. I am taking a table like 6 table. 6 3s are 18, 6 4s are 24, 6 5s are 30. Now while you are observing here, 18, 24, 30, these are all coming in 6 table. So we can say that 18, 24, 30 are multiples of 6 because all are coming in 6 table. If 18 is also comes in 2 table, right? So we can also 18 as also called as multiple of 2. We can call 18 also multiple of 3 because 18 is coming in 2 table, 3 table, 6 table or 9 table also. So 18 is a multiple of 2, 3, 6 and 9. Clear? Now for example, see here 6 and 3. 6 3s are 18. 18 is multiple of both 6 and 3 and 6 and 3 are factors of 18. So simply the factor definition is when two numbers are multiply each other. Two numbers are multiply each other. Each of the number will be factor to the product. What is the definition? Two numbers multiply each other. Yeah, when two numbers are multiply each other, each of the number is factor to the product. Each of the number means here 6 and 3 are factors to the product. Product means what? Product is nothing but the result when you do the multiplication. Okay? Right. So each of the number is factor to the product. Right. That is the definition of factor. Multiples means the numbers which are coming in the same table or can be called as multiples of that number. Okay? Here 18, 24, 30, these are all multiples of 6. They are all are coming in 6 table. Clear? Yes. Now let us discuss about a prime number. So prime number is nothing but a number having only two factors. Prime number means a number having only two factors are called prime numbers. Or number having exactly two factors. Exactly two factors. Okay. So for example, I am taking a number like 1. 1, 2, 3, 4, 5. Like I am just taking the numbers like 1 to 10. Now let me decide how many prime numbers are there in this 1 to 10. Okay. I am writing 1 as 1 into 1. 1 is coming in only one table, 1 ones are. Both are same numbers, so it is having only one factor. 1 is having only one factor. Let us come to number 2, which is coming in one table. 1 into 2, 2 and 2 into 1 also 2. That means 1 and 2, 2 factors. 2 is having 2 factors only. What about 3? 1 3s are 3. 3 will come in any other table. 1 3s, 3 ones, both are same, right? So it is having only 2 factors. Now coming to 4, how many factors does the 4 has? 1 4s are 4, 2 2s are also 4. That means here 1, 2, 4. How many factors? 3 factors. Now coming to 5, 1 5s are 5 or 5 ones are. So 1 and 5, 2 factors. Coming to 6, 1 6 are, 2 3s are also 6, 3 2s are also 6, right? So 1, 2, 3, 4, 4 factors. 6 is having 4 factors. 7, 1 7s are 7, only 2 factors. 8, 1 8s are, 2 4s are, 4 2s are. Whether it is repeating now, so we can stop. 4 factors. 9, 1 9s are, 3 3s are. 3 3s are also 9. So how many factors? 1, 2, 3 factors. Here 3 is repeating 2 times. So we have to consider only 1 time. Okay, 3 factors. Now 10. 1 10s are, 2 5s are, 5 2s are. 2 5s are, 5 2s are same. It is repeating. We can stop. So here 1, 2, 3, 4. Now see, while you are observing 1 to 10 numbers, 1 to 10 natural numbers, the numbers only having two factors. Let us identify the factors. The numbers which are having only two factors. That is nothing but 2. 2 is having only two factors. Number 3 only two factors. Number 5, number 7. That's it. So 1, 2, 3, 4. So we have to say these 4 numbers as prime numbers because they are having only two factors. Clear? And what about 4, 6, 8, 9, 10? So number 4, number 6, 8, 9 and 10. These are all having more than two factors. These numbers having more than two factors. So we have to call these numbers as composite numbers. So when the numbers having more than two factors are called composite, exactly two factors are called prime numbers. Exactly two factors, such type of numbers are called prime numbers. Okay, more than two factors, composite numbers. But what about 1? 1 is neither prime nor composite. 1 is neither prime nor composite. Okay. So while you are observing natural number system 1, 2, 3, 4 and so on, while you are observing all the numbers in the set of natural numbers except 1, remaining all numbers are considered as prime numbers and composite numbers. That means they are arranging in a manner like prime numbers and composite numbers. All the numbers except 1, they must, means every number which is related to prime number or related to composite number. Any one of the group it will be. These numbers will be. Okay, right. So like that, 1 to 10 there are 4 prime numbers and 5 composite number. One number is neither prime nor composite. Now 1 to 100, how many prime numbers are there? 1 to 100 there are 25 prime numbers. Okay. 1 to 50, 1 to 100. 1 to 50, there are 15 prime numbers. 1 to 100, 25 prime numbers. That means 50 to 100, only 10 prime numbers. 50 to 100, only 10 prime numbers. Clear? So, what are the prime numbers are between 1 to 100? You just check, cross check like this, how I am doing this. 1 to 10, same manner you apply to 1 to 100. Take all the numbers, try to write their factors, and what are the numbers having exactly two factors, such numbers is considered as prime numbers. More than two factors, we can take it as a composite numbers. Okay, right. You try at your home, what are the numbers you will get for 1 to 100 as a primes. Okay. Remaining all composites, we can take remaining all composite. That means 1 to 100 there are 25 prime numbers, then 74 composite numbers, because 1 is neither prime nor composite. Okay? Yeah. Now let us go to standard form of a number. We have discussed that standard form of a number. Before going to discuss about the standard form of a number, we should aware of fundamental theorem of arithmetic. What is the fundamental theorem of arithmetic? I have written here, every composite number can be expressed as prime numbers. That means we found here 4 to 6 means 5 composite numbers from 1 to 100, 1 to 10, right? Those all 5 composite numbers we can express as product of primes. Let me check. For example, I am taking 2, okay, 9. I am taking 9. 9 we can express it as product of primes. 3 3s are 9, 3 1s are 3. That means 9 can be expressed as product of primes. Both are prime numbers only, 3 and 3. Okay, no? So like that, every composite number can be expressed as product of its primes. Right. Now standard form is nothing but we are applying the fundamental theorem of arithmetic into the number. That means if you take one composite number, that composite number can be expressed as product of primes. Writing the composite number as product of primes is called its standard form. Okay, no? Right. For example, 28. 28 is a composite number. Now here you should remember that while you are taking prime numbers from 1 to 100, 1 to 10, there are 4 prime numbers, right? 2, 3, 5 and 7. There are only 4 prime numbers from 1 to 10. While you are observing 2, 3, 5 and 9, 3, 7, 9 are odd numbers. Odd numbers means they never exactly divided by 2. Only 2 is an even number. So, if you take any even number, except 2, they definitely becomes a composite number. That means we have one and only even prime number is 2. One and only even prime number is 2. Clear? Right. Now I am taking 28. 28, let me try to express as product of primes. And while you are observing the composite number, the product of primes or prime factorization of a composite number is unique. Unique means if you do the prime factorization or I do the prime factorization or any one of them are doing the prime factorization for any composite number, you will get the same prime numbers. Order might be different because I will start with number 2, you can start with number 3 or someone can start with number 5 or 7. So whatever the numbers you can start, it doesn't matter, but the prime factorization is unique. Order is not important here, but the presence of the prime numbers is important. Okay, that's why we can call that for prime factorization of a composite number is unique. Now I am taking 2 table here. So 2 table 14 times. 2 14s are 28. 2 7s are 14. 7 is a prime number. 7 1s are 7. So 28 can be expressed as 2 into 2 into 7. 2 into 2 is nothing but 2 square into 7. This is the standard form of a composite number 28. Okay, right. Now let us discuss about the number of divisors. Today we are going to discuss about the topic of number of divisors. Very, very important. So there are two different methods we are using to find out the number of divisors or number of factors of a composite number. Okay. So let us see both of the models, then we'll choose which one is easy for us. Okay. Now, number of factors. Number of factors we can call or number of divisors. Okay. Number of factors or number of divisors. Okay. Let us see. For example, number of divisors of a composite number 120, or let us try with the small number 36. I am taking the composite number is 36. Now I am just using the general method. General method is nothing but I am just choosing one by one table from the set of natural numbers. I am just taking the every number. Okay, which number is exactly divisible or which number will be the factor of 36. Okay, one table 36. Yes, 1 is a factor of every number. Every number will come in one table. So 1 is a factor of every number. So 136 is a 36. One table. Now let us check 2 table. 2 table 36. Yes, definitely will come because 36 is an even number. So 2 table 36 18 times. Now 3 table 36. 3 12s are 36. Yeah, 4 table, yes, obviously 4 table also getting. 4 table 4 9s are 36. 5 table is not, 5 is not a factor of 36. 5 table 36 won't come. So let us go through 6 tables. 6 tables, 6 are 36. 6 are 36. Here we no need to check 7 table, 8 table and all because here 6 and 6 repeating. Both are repeating, we can stop it. So let us try to count the number of factors. 1 is a factor. 1, 2, 3, 4, 6. 6 is repeating now. Next 9, 12, 18, 36. Here 5 and 4. Total number of divisors or number of factors are nothing but 9. Number of divisors equals to 9. Okay, right. Now the same question 36. The composite number, same composite number. I am doing in a method of prime factorization. So I am taking only the prime numbers. So 2 table 36 18 times. Again 2 table 18 will come. 2 9s are 18. Now 3 table 3 3s are 9. 3 1s are 3. That means 36 we can write it as 2 into 2 into 3 into 3. This is nothing but prime factorization. Nothing but prime factorization. Okay. So 2 into 2, 2 square. 3 into 3, 3 square. Now after completing the prime factorization, now number of divisors. Just listen carefully how I am doing this. Number of divisors. Now while you are observing here 2 power 2, 3 power 2. Both powers are 2. Both exponents are 2. Now I am taking this exponent 2, I am adding 1 to this number. 2 plus 1. Second exponent again 2 plus 1. So 2 plus 1 is nothing but 3 and here also 2 plus 1 is 3. 3 3s are 9. Therefore number of divisors are 9. But some are feeling that sir, the regular process is somewhat easy, right? Than this? No, definitely not, because 36 is just a 2-digit number. We can identify all its factors by checking one by one table. But here, when you go through 3-digit numbers and 4-digit number, while checking each and every table is somewhat difficult for us. Time taking process. So that we are using this prime factorization method. Okay, let us see. For example, I am taking a 3-digit number like 140. 140 is a 3-digit number. I am trying to identify all its prime factors, all its factors or number of divisors, number of factors. But I am not taking the regular method 1 by 1 table, 2 table, 3 table, not like that. I am just taking the prime factorization. So 2 table will come definitely, 2 7s are 14, here 0. 2 70s are 140. Again 2 table 35 times. Now 5 table 7 times, 7 table 1 time, completed. How easily it is coming. But while checking 140, you should go up to 10 table also. Am I right? Yeah. Because 10 14s are 140. 1 table, 2 table, 3 table, every table we need to check like the time taking process for us. So directly prime factorization. So 140 can be expressed as 2 into 2 into 5 into 1. These 2 we can read as 2 square. Now this only 5 is presenting only 1 time 5 power 1. 7 presenting also 1 time 7 power 1. There are 3 prime factors. There are 3 prime factors. Therefore number of divisors. Number of divisors. First exponent is 2 plus 1. Second exponent is 1, 1 plus 1. Third exponent is also 1, 1 plus 1. So 2 plus 1, 3. 1 plus 1, 2 and 1 plus 1, 2. So 3 2s are 6, 6 2s 12. There are 12 factors. Number of factors of a composite number 140 is 12. Okay. So based on this, can we derive a formula for this shortcut? Just look into it. Yes, we can write a shortcut for this also. That means a composite number n. I am taking that n is a composite number. If n is expressed as product of primes p1 and their exponents n1, second prime number p2 power n2, p3 n3 and so on. Then number of divisors, very important. The number of divisors is n1 plus 1, n2 plus 1, n3 plus 1 and so on. Okay? Yeah, that's it for today children. Thank you one and all. Have a nice day. Bye-bye.